several years ago, an idea came out of the Technical Advisory Committee at Geoscience BC to initiate a project that brought together exploration data and geological knowledge over BC porphyry districts. The idea was to use the data that we have available, historical data, modern data, over the systems that we have a lot more knowledge of, the more advanced porphyry districts, to generate insight into district scale features that we can see when we integrate that data, district scale targeting ideas that can come out of integrations like that. BC is well known for its porphyry systems. In addition to operating mines, we have numerous occurrences in the BC MinFile database. I've culled those here to show you only those that are most likely porphyry related, still a huge number throughout the province. And they include different ages and different classes of porphyry systems. Those related to the Triassic-Jurassic arc terranes, such as calc-alkalic systems like Highland Valley. Also alkalic systems, well-known BC systems, for example, at Copper Mountain. Younger primary moly systems, and also younger Cretaceous age copper moly systems. Huckleberry would be an example. Now, these occurrences represent over 100 years of exploration in BC. From the days when exploration was done like this, it's always good to revisit the way things were before. This guy got here on horseback or by foot, and that was less than 100 years ago. Since then, we've seen a lot of innovation, and this is some of the equipment that we're using today with airborne geophysical surveys, innovative technology, some of which are being flown by unmanned aerial vehicles, and equipment and instrumentation that's helping us see chemical composition, chemical knowledge of rocks in more detail, faster, and cheaper than ever. So that all leads us to a really data-rich environment in BC where we have regional, publicly available data sets, a lot of knowledge in industry in terms of more detailed geophysics and surface geochemical surveys that date back over 50 years. For more than 50 years, we've been collecting geochemistry, surface geochemistry in BC. Also, ever-increasing resolution and detail in our geological mapping. And probably most importantly for this project is we know more about models for porphyry systems than ever, some of which have been developed through studies on BC porphyry systems, for example, again, the alkalics. So the opportunity through the Porphyry project was to bring together as much of this as we could at the district scale and see what comes out of that, see what we can generate for information in district scale targeting. What do the alteration features look like? What do the mineralized zones look like in the geophysics, in the geochemistry, and what we know about the geology? At the start of the project, we cast a wide net over a lot of districts and gathered together everything we could, public and the public side. We also recognized, however, that there's a lot of information out there in industry, a lot of experience, a lot of expertise. And so we went about forming collaborative arrangements with various companies and had good success there as well. Then the next step was to bring together as much of that expertise as we could. And my hope originally was that we could get people talking. We could get a lot of really smart people in a room with a lot of knowledge, and we get them talking about things and generating all kinds of great ideas. So we tried the workshop approach, where we'd have people come and we'd talk about things, which was marginally successful. Came up with the idea of developing some products that brought together different expertise, where people could contribute different parts of the product. Again, it was going in the right direction, but what we soon came to realize was that we needed maps. We needed hard copy products or digital products that were formatted to look at, to talk around, to share ideas over. And so we came up with a whole set of products out of that idea, and I'm going to show you the results of one of those over an important BC Porphyry system right now that was just released today. You may have seen it's printed out in the lobby. The Endako district. So this was a compilation between Geoscience BC and Thompson Creek Mining Company, with special mention to Michael Pond for making it happen within Thompson Creek and for his dedication to the project. Also contributing are Dave Heberlein, Peter Kowalchuk, and Ward Kilby, who have all contributed layers that went into this product. This is a view to the east over the Endako pits. To the south is Francois Lake. And Endako has a long history in BC. It was originally discovered in 1927 by two local prospectors who discovered a significant quartz molybdenite vein in the area of what's now excavated as part of the Endako pit in the Endako West ore zone. You have to think that was quite a fortuitous outcrop because a lot of the area is covered by glacial till. And interesting from a historical perspective is that Endako sat for quite a long time after that. Until the early 60s, it only saw limited interest, and a large part of that was the challenge of exploring through that till, through the glacial cover. So the innovation that happened, the change, was in the early 60s when it was brought along and optioned to placer development. And through the expertise within placer and the connections within placer, they brought the new technology of wireline drilling to BC. And I've been told that Endako was the first project in the province to see wireline drilling at that time. So that really opened Endako up. And the ability to drill faster and deeper and more efficiently, work towards defining the ore body very quickly. And Placer worked on that for about 3-4 years, and then opened the mine in 1965. So within 4 or 5 years, went from ore body definition to mine building. Endako was then sold in 97 to Thompson Creek and their Japanese partner, but it operated for over 5 decades with only limited breaks in production. And earlier this year, you will have heard that it's gone on care and maintenance, but there are still reserves in the Northwest ore zone that might be part of the future of Endako. Regionally, geologically, Endako occurs within the Endako batholith. All the rocks here in pinks and purples are part of the Endako batholith, a late Triassic to late Jurassic composite batholith, with the outermost parts being more mafic, foliated diorites, and a central part of more granitic rocks, more highly chemically evolved part of the batholith, which are mostly late Jurassic. And they host the low fluorine type mineralization that we see here at Endako, known mineralization at Nithi Mountain, and numerous occurrences to the north of Endako through here. Also important are the post-mineral volcanic cover rocks that occur across this map in green, late Cretaceous and Eocene volcanic cover through a lot of this area. I'll draw your attention to those zones of mineralization, again, in that more granitic, more highly evolved part of the batholith, and keep your eye on those when we bring up the gravity data, and you'll see there's a strong correlation between that low gravity anomaly and the occurrences at Endako North and Nithi Mountain. You might say they occur on the margin of the gravity anomaly, but regardless, there's interest in the low gravity signature here. So you might wonder about areas like this to the south that all have a similar low gravity, no mineral occurrences known over on this side and up in here. But you'll see when we bring up the post-mineral volcanic cover that there may be opportunities in those areas as well. In more detail, Endako occurs within one of the latest phases of the Endako batholith, and particularly within the Endako quartz monzonite in the darker purple here. The ore body is shown here as the limit of the 0.042% molybdenum sulfide grade thickness contour that defines the Endako ore body. This section line here is shown off to this side, looking to the west. And the Endako body in the southern part is a set of steeply dipping quartz molybdenite veins with associated potassic alteration, particularly in the footwall, with phyllic alteration around the southern side and extending up to the north, where the veins shallow to the northwest and are associated more with phyllic alteration and later argillic alteration. So important here to note are the limits of the Endako quartz monzonite, and I'll show you the magnetics. Now, this is a composite magnetic image focused on district scale, high resolution aeromagnetic survey that was donated by Thompson Creek. And you'll see that there's quite a lot of complexity in here, but I'll draw your attention to the zone associated, the features associated with the Endako ore body, which Diane Mitchinson studied in her work with looking at physical rock properties to support and characterize geophysical interpretation. So on the southern limit of the ore body, where you have more potassic alteration, Diane was able to show through her measurements that all the alteration actually at Endako has low magnetic susceptibility compared to the rocks that are less altered within this Endako coarse monzonite zone, which is a good correlation, of course, with what we see in the magnetics. So there's a good explanation for this low magnetic signature. As you go to the north, you don't see the same, but as I said, there's less alteration up there, less potassic alteration, and a lot more of this late argillic alteration. But interesting that that magnetic feature continues off this way, and there's a lot more to be looked at, obviously, in this data that can use some more interpretation from the geology. So I mentioned that drilling was critical to Endako's discovery, but also really interesting from a historical perspective is the use of surface geochemistry at Endako. This is a photo, this is 1954, what things looked like on the ground there at Endako. And during the time around that, just shortly after that image was taken, from 1960 into early 70s, Placer and Associates took over 10,000 soil samples along the Endako corridor. Using colorimetric methods early and then onto atomic absorption, we'll show you, I want to emphasize that this is historic data. This is data from 1960s that we've been able to take into this compilation, reprocess to show you a gridded image of leveled soil data shown as Z-score analysis. This is what things look like. Note the scale, 5 kilometers. So this is an over 10 kilometer anomaly, soil anomaly, by 5 kilometers wide over the Endako area. Now I've already shown you where Endako sits, but if you have a look at where the highest values occur, you'll notice that there's a sharp break along this western side, and you can imagine where the Endako ore body sits. So that's the Endako ore body as we know it today. But remember that they didn't have that back then. They had this really large soil anomaly in B-horizon soils over till. So interesting use of taking the historic data, reprocessing, and what a great image we have for the features at Endako in the surface geochemistry. Also instructive and interesting is to overlay more recent biogeochemistry on that map. Both Dave and Colin have shown the results of their respective involvement in these surveys in the 90s and then even just this year with the spruce sap sampling. And we'll see that the highest values in biogeochemistry, although they do correlate as well with some parts of the Endako ore body itself, some of the highest values in the biogeochemistry sampling for moly occur over this zone of highest values in soil as well. A really good correlation. So there's a lot more information in the Endako files, and I encourage you to go and look through the atlas and all the digital data that we brought together for it. You might be thinking that you're more interested in alkalic copper gold systems. So we have Mount Poly up next. It'll be out very soon, we hope. And interesting, Mount Poly's late Triassic alkalic copper gold porphyry system, which is also interesting from a historical perspective, as there was a quite complete multi-element soil survey done in the 80s over Mount Poly, which is all pre-mining. Mount Poly has complex geology and alteration, so we've been fortunate to be able to facilitate the publication of a new geology map for a district-scale geology map over Mount Poly, which is the result of years of work by Chris Reese and others on mapping around the Mount Poly system. So he presents updated geology, updated alteration, and the distribution of copper and gold mineralization at Mount Poly. I highlight this because it's an excellent example of the way we've been able to bring information from industry into the project. And I know that there's a lot more out there that I think all of us would benefit from seeing in a more organized and readily available form to study some of the other important porphyry systems out there. So it's been said that one of the challenges that we have today with all the volumes of data out there is turning that data into useful knowledge. And as we've seen, there's a lot of talk about integrating data, and it really is the way to go. You have to bring that data together in order to generate useful knowledge from that. So we've got a really good database of more raw data and publicly available data over some of these other BC porphyry systems, and we hope to be able to bring that into formats that are more accessible for everybody to see and learn more from and carry that knowledge forward. Thanks very much.